Hello friends, in this video we are going to have a look at some of the system logging facilities that are available in Linux, and specifically we will be looking at rsyslog, and also its predecessor, which was syslog. And also, what about syslog NG or syslog next generation? Now they all serve the same purpose, that is, if we have got our machines, not only that Linux machines, but any machines that support logging facilities, and we want that what messages are, or what is the health of the machine, how much memory is consumed, whether there was some interface up, down, some process got stuck, some process got killed, or there are some other parameters that can be set in syslogging for informational purposes. Maybe some mails were sent, or some mails were, or mail queues were full and could not be sent. So all these facilities can be logged in using syslogging facility. This syslog ng and rsyslog, basically they are all the same in the way that they all permit to log data from different types of systems in a central repository. So it's not that just we have got multiple Linux machines like this one. These could be network elements as well. Maybe these are routers and switches and modems and other network devices, all those kind of devices that support syslogging facility. And we have got a central Linux syslog server over here. Then through these network devices could be switches like this one. They can all be connected through the switch, and in turn the switch can send all the syslogging information regarding all these devices to a central repository, where we will have a central NMS that we may connect it with, so that we can diagnose what is going on with our network. Now, as I mentioned, that all these three, they serve the same purpose, but they are in fact three different projects, and each project trying to improve the previous one with more reliability and functions. The syslog project itself, this one, it was the very first project, and it was started in 1980. And you can say that it is the root project to syslog protocols. It's like the daddy of these other two versions. Now, when this syslog was developed, it was very simple protocol at that time, and it only supported UDP for transferring of packets between different systems. And since you know UDP does not support any guarantee of delivery of packets, since it's unreliable, so very rudimentary and basic functionality as far as basic or the initial versions of syslog server were concerned. After that, in around 1998, syslog next generation, this one, syslog next generation, it came out. And what it did, that it extended the syslog protocol with new features. So it extended the features, it supported features like content based filtering. It also supported logging directly into a database, so logging into a DB. It also supported TCP. Remember that earlier versions of, or the primary version of syslog, it only supported UDP, but this next generation syslog, it supported TCP as well. And also it supported TLS encryption, so that we can send encrypted packets between the devices, remote devices, and the syslog server. Then in 2004, rsyslog server came out, that is by default used in most of the Linux distributions today, and it extended further syslog facilities or syslog protocol, and it added some new features, and one of those features was RELP, which stands for Reliable Event Logging Protocol, and it also supported buffered operation. So buffered operation was also introduced by syslog server. So it's not that syslog or syslog next generation, they have been superseded. Of course, they have been superseded by syslog, by rsyslog, but they have not been put out of the industry yet. They are like three parallel projects that have grown separately upon different versions. Syslog next generation, you can say that it is the most easiest to configure and provides a comprehensive and easy setup as far as installation is concerned. But by default, in Red Hat based and in Debian based distribution, our syslog is there, and we are going to see that how we can configure that to manage our machines or to manage the syslog logging facilities from different devices onto a central server. Now, when we talk about syslogging, let me clear this slide. So when we talk about syslog facility, it means it denotes a way to categorize internal system processes. Now in Linux, some of the common standard facilities are auth. It is written as AUTH, and it contains messages that are related to authentication. For example, login success maybe, or even login failure. So if we are to record these kind of messages, then we have to have this facility enabled in the syslog file, and against that we'll see what actions need to be taken. We'll see that in just a moment. Another very important facility that is available by default is cron, and messages related to cron daemons or scheduled processes are put in this facility. Another one is daemon. Messages related to different daemons or internal servers, they are using this facility. Then we have kernel facility, which holds the messages for the kernel of the operating system. Then another important one, and by default available, is the mail, which relate to internal mail servers. Then we have syslog itself. This is also a facility. So the syslog related messages, the syslog system that will be running on our Linux machine, those messages will be logged in using this syslog facility. We've also got LPR. So this is small LPR, and this manages messages related to print servers. You will also find messages of facility type local 0 to local 7, maybe 0 or maybe 1, 2, 3 up till 7. And these are the facility types that are mostly defined by the users. Normally Cisco, which is a networking vendor, and also Windows, they also use this local 7 syslog facility. Now these facilities are the most common ones, and most of them are configured by default, which we'll see in a while in the configuration file. But these are just the facilities. There is another provisioning that we have to define, and it is a good way of defining logging facility, that what severity level should be logged for these facilities. Like if there is authentication or maybe system level, kernel level messages, then should we need to know about all the kernel level messages? Like if they are not having any impact on the system performance, maybe they are just for information purposes, do we want them to be logged in or not? So this is where the concept of severity level comes in. By default in Linux there are 8 levels, starting from 0 being the most significant or the most severe, which is called as, so let me just write this one, 0, 1, 2, 3, 4, 5, 6, 7. So starting from 0 and wow, I removed this one, very nice. So let me put this one. Okay, so starting from 0 to 7, the topmost, which has a severity level of 0, but it is the most significant. So lower the number, the most severe the level is. So 0 is emergency. It's like, you know, when something goes bad and it's an emergency situation, then definitely you would like to attend this one at the earliest. Then we have alert severity level, which is one level below than the emergency level. And then we have critical level. After critical, we have errors. So you can pretty much imagine that emergency has got far more severity concern than the errors, because errors would still mean that the system might be working, but emergency means that something has really broken up in your system. Then after errors, we have warnings. Then we have notifications. And after that we have information severity level, so information. And the last one is debug, where you just put in each and everything, whatever is possible you want it to get logged. Now once we will be looking at the configuration file of syslog server or syslogging processes, we'll see that the syntax that we want to define in there is something like facility, which is like this part over here, facility, and then dot severity, or also called as priority. Now I must also tell you that if let's say we are setting a by default, this happens by default, that if we are setting a level of facility, let's say kernel, as that of warnings, so I say that kernel dot warnings, so warnings, then primarily what we are trying to do is let the syslog facility inform us about the kernel facility level messages whose severity should be warning. But what about if an emergency comes in? How about those messages? So by default, what happens that if you define a level, then the severity levels which are above of that level or more severe than that level, they also get logged in by default. So if you are defined warnings, then it would mean that errors, critical, alerts and emergency messages, they will also be logged in this facility that we'll be defining using a file maybe, or maybe send it to a remote host. So now let's get on to the terminal. Let's see some of these settings and have them in working order. Here I am in my Ubuntu box and the configuration for syslog itself remains the same more or less as far as Red Hat based systems are concerned, but it's just a path or the file name that gets changed. Over here the path is normally in etc r syslog.d and then the configuration files by default, but in case of Red Hat it's normally etc and r syslog.com. So let's just check now Ubuntu, and if we have got time we'll see that in CentOS as well. So let's just first see the contents of etc, then r syslog.d, and we have got two files. This one is for firewalling and this one is the default syslog file. Now if you want to see the contents of this file, and let me just also see the permissions level of this file. So we see that it is word readable, anybody can read it. So let's just try to read it. Let's just vi this file by typing in vi and then the path, which is r syslog.d and then the default syslog file. Now this is saying that we are in read-only mode. Of course I am in read-only mode. Now if I come down below, we see that this is the thing that I told you about, that auth is the facility level, and after that it's comma, because we are separating two facility levels with a comma, and this one is auth privacy or encryption level or authentication level facilities. Then it comes the dot, which is a separator for the facility and the priority, and then we have got static. So anything related to auth or auth privacy should be logged into this file, which is var log auth.log. Now if we come down below a bit, we see that everything, this is everything, and after that we have this semicolon. It says that auth.privacy.none, but everything should be logged into var log syslog. And if you have a look at this, this is not just a simple path, we have a preceding dash in front of it as well. Now this is there, this dash here signifies that once the logging has been on and there are many logs coming in, log messages are coming in regarding this static.static, which means that everything, then do not write those messages straight away on syslog file, because then it would mean that since everything will be getting logged, so a lot of log messages will be there. So instead of keeping the disk engaged all of the time, instead of doing that, first keep on accumulating the messages in the RAM, in the memory, and then periodically dump them on the syslog file. So this dash indicates that keep the contents in the memory and then dump them periodically. Then we have got this cron, which is we see that it is commented, but all the levels or priority gauge crons should be logged into cron.log. We can remove this static and this will be getting logged. Similarly, we have daemon facility as well. In daemon.log file, we can have kernel messages which will go to kernel.log, and same like printer, mail, and user. These are user-based messages which can be logged into user.log. Now, you might be asking yourself that why can't we do something like that, static.static, and then put them in one file? Well, the reason is that you can do that, and if it's a small system, then it's all right. But in production level systems, you have got so many logging facilities, you have got so many processes running that sometimes it becomes cumbersome to go through a log and look out for a specific process-based message. Of course, you can use the text manipulator, like you can use the grep for finding out, but it's normally it's better that you have separate log files related to separate core processes, like maybe mail or maybe kernel or maybe authentication or even user. So usually it is recommended, and it is a practice, and it is a recommended practice from my side as well, since I have used it many times, that important facilities files should be separate in the system as compared to putting them all under one file name. It makes your life easier. Believe me, once you do that, you will see that it is far better to go through the files which are process specific instead of going through one single file.